Hello and welcome back to the series where we're writing a mini Rust in Rust. This is video 15. We have achieved some kind of milestone, which is that we wrote a bit of code that's sort of meaningful. We put a value into a variable and then we got it out again and used it in a calculation and we got the answer 7 out. Now there's loads of things we know are not right. So for a start, we're getting back a list of values. And I've been thinking more and more that evaluating an expression like this, or what is this? It's like a sequence and an expression. It's like a expression sequence or something. Should be giving us back just one value, not a list. Also, we had this thing of does a statement return a thing which is called a unit, or some lack of thing? And I went back and forth on that. I'm pretty sure it should. But I'm putting all of that on one side because I think that if we think about type checking, some of this stuff might start coming together, I think. And I started thinking, well, maybe we need to be able to write a function before we can do type checking, but I reckon not. So what I'm going to do is our guiding test for this is, let's say, assigning the wrong type is an error. And I guess this test doesn't actually belong in the evaluator. We'll think about that in a second. So what I'm going to say is this. I don't know whether we want the semicolon or not. I mean, really an assignment should always have a semicolon at the end of it, so it kind of makes sense. Now, we're not going to be able to use eval v because eval v assumes that there'll be no error. Does some kind of expect here. So instead, we're going to need to do something a bit like this, where we call just eval, and then do some unwrapping and expect it to be an error. So let's do that. So instead of eval v, which is our little utility function, we'll just do eval. And then we'll get the next thing, so the first thing out of that evaluation, which is there should be only one thing in there. And now this is, I think that's an option, is that right? And eval needs an environment, or no? It needs it needs some code. Yeah, okay. So we need to let we need to let we need to just put the code into a variable because we're going to pass it in two places like this. So we're going to evaluate code, comma eval of code. No, what am I talking about? I'm going to pass in. We're going to do eval of code, comma. All right. Yeah, I was missing out this whole thing. We have to parse the code after lexing the code, and every time we call parse or lex or eval, we pass in code as well because we're using it to use build error messages based on that original source. And when we're lexing, we also need to do this stuff, of just ignoring errors, basically. Like so. Maybe there should be a utility function for this parsing and lexing thing. Kind of feels right, doesn't it? All right, let's write that. Okay, so let's do. But I think it's called parse v because it returns a vec. This isn't going to return a vec, so let's call it parse. I want this to be a short name, but I want it to be, let's just call it parse unwrap. Basically, you give it some code, it does this whole business for you, where code is a str. And I'm not sure what it returns. What does it return? This should be parse unwrap. of code. And it should be returning basically an iterator of, so something that implements iterator where the item is a whatever parse returns. What does parse return? A parse of I, where I is an iterator. That's a bit confusing. Hold on. What does parse actually return? Yeah, just something that implements parse, I guess. What? No, what is this? I don't want to have to write this. This is too difficult. I guess that's why we're returning a vec in that other place. It's going to be a parse of, I mean, it's just a nightmare, this. Dealing with these types that are dependent on other types that depend on other types. Yeah, so it's returning a parse. And then what does eval expect to be given? I guess that's where we need to go with this. What does eval expect to be given? Expects to be given an iterator with an item of syntax tree. Okay, that's what I needed to know. And actually, I had that information there, right? If I go into parse, look at this parse struct, then you can see it implements, somewhere it's going to implement iterator, right? And the item is a result of syntax tree. And then we're unwrapping that to make it just be a syntax tree. And it seems happy. Does it seem happy? Seems happy. Okay, so back to what we were doing, which was assigning the wrong type is an error. We're going to call parse unwrap on code. And parse unwrap is going to return. Do we need some more unwrapping maybe? Hold on, what does parse unwrap return? Returns an iterator. Then eval returns a values. But next returns. Oh yeah, we need an unwrap error here. Yeah, so next returns a option, and inside there is a result, and then the result is going to look like some kind of error. I should have copied the test below, really, shouldn't I? It's doing the same stuff. So we've unwrapped an error, and now we're going to assert that the error, when we format it, looks like some string. So let's just copy the whole of this. It's going to look totally different, but this will help us. For now, we'll just put in some kind of placeholder, like wrong type, you fool, or something. So the point is, we're saying please let x be an i32, and then we're giving it 3.0 as the value to initialize with. Now, another thing we've done wrong, by the way, is that all these integer literals that we've given here, we've immediately interpreted them to mean i32. And actually, we need to be clever. We won't do this now. We'll do it some other time. But we need to be clever about that, because this could be an i64 or a u64 or a usize or something else, or even something that's hugely too long to be allowed. We could still allow. So yeah, we did that wrong. We shouldn't have said i32. We should have said integer literal, which means I haven't decided what type this is yet. And when I do my type checking and my type inference, then I'll figure out that what type you meant, and then I'll check that this is actually a valid one of those. But we won't do that this time. What we will do, though, is allow, maybe not this time, but we'll allow floating point literals, and then we'll do some type checking to check, look, this is not an integer, so this is wrong. Yeah, and exactly how, like at some point we're going to be doing type inference. At this point we might be doing something dumb, like this is an assignment statement and we've said the type, so we've got to check it now, and then we'll get cleverer over time. But yeah, so this should definitely, something should go wrong when you run this code, and maybe this is a good time to, like what I planned for this language was that we were going to write little Rust programs, figure out what error message they printed out when they went wrong, and then try and produce almost exactly the same error message in our language. So maybe this is a good time for that. And then notice that there's quite a bit we need to do before this test is actually going to work. So this test is immediately going to get ignored because we need to be able to parse this statement that means we need to be able to lex colons, which we haven't done yet. And we need to parse this symbol, which is probably already there. But this structure of assignment, the optional type here is not yet parsed, so we're going to need to do that. And also we're going to need to be able to lex these floating point literals that we haven't done yet either. So there's quite a long way to go before we get to the bit we're actually trying to do, which is the type checking. So we definitely won't get to it all this video, but let's do one thing, which is to make a little Rust program, which is exactly this. And, well, with some surrounding stuff, and then see what Rust prints when that happens. So let's, we've got the wrong size font. Let's go to our desktop. Cargo new. What should we call it? Wrong type assignment. Wrong type assignment. Go into there and put in our bad code. And then run the compiler. Cargo check. So it would be nice if we could produce exactly the same message, maybe without this error code, because we haven't. I mean, error codes are an idea, aren't they? Huh. So, at least this stuff should look similar, if not the same. So for now, let's put in as much as we can of that. And make it look as nice as possible, and then we'll see whether we can get close to that or not when we really do it. So what are we doing here? This is not laid out exactly the way I would like, but well, for now it doesn't really matter, I guess. How does my code formatter feel about that? It's okay. Alright, so how does it look? It looks like it's one space here. So the dashes are under the R's. And the number 2 is directly under the E of error. So we've got messed up here. And these have all got to be... Yeah, alright, so the alignment here, we're going to have to do this kind of pain or use the dedent. Something else I was doing today, I used the dedent macro from the text wrap module, which might be a package, which might be great, that's what they call it, which might be good to do later, but anyway. Suspected an I-32, but found a floating point number. Notice it doesn't say found an F-64 or something like that. It says found a floating point number because, like I was saying, the literal is of type floating point, but we don't yet know what type of floating point it is. Anyway, that gets us a little bit closer to the kind of error message we're expecting. I guess this error code, we could try and exactly match Rust's error codes. I don't know. All right, we'll think about that later. Anyway, okay. So we have a test, which we're definitely not going to be able to get parsing. Let's see what happens when I run it. Okay, we've got lifetime problems, and we need to do a use in our parse unwrap function to make sure that the lifetime that's implicitly coming through in the iterator gets exposed. I can't get my head around exactly, but it's something like what I just said. So there's like a cool feature in the new version of Rust that means this won't be needed in Rust 2024, I think. Okay. So basically the compiler's telling us just do this change even if you don't care what it is. Okay. We called result unwrap on an error value. Hold on. Line 203. We called unwrap on an error value. Oh, yeah. Okay. Okay. All right. So we did an unwrap here. Or was it here? Trying to parse this colon. And it gave us a lovely error, which we then unwrapped somewhere in one of the many unwraps that we did, saying, I don't know what a colon is, which is fair. So we're going to ignore this test. And I think for this video, let's just see whether we can at least make this much stuff lex and parse. And then we'll probably be done. So now we run the test, it's going to get ignored. But we're working our way towards, this is like our guiding test again, we're working our way towards this statement, parsing, and then hopefully getting an error message. And really, this should be, let's say this, to do this should be in the type checker, or with the type checker code. We don't have a type checker yet, so we're leaving it in the evaluator for now. All right, so how are we going to do this? Well, first thing is, I guess, we're going to have to lex this same statement. So let's look at our tests for the lexer and stick one on the end. Well, maybe not right on the end, because it's errors right on the end. There are other errors. Everything. I feel like there ought to be more tests for errors. But anyway, let's go here, shall we? And make another test. Looks a bit like that test. And it says, can lex. Is it going? Can we say anything better than can lex? No, can lex. Optional. No, what is it? This'll do. Can lex optional type on assignment. I mean, it's not really even that, but I can't think how to put it better. So basically what we're saying is, when I lex this, it works. Now I'm going to actually cheat and say, for now, we're not actually lexing that whole statement. We're just going to lex the a valid assignment of 3 with this type specifier there, and not an invalid one, because then we'd have to be able to lex 2 things, which is the floating point as well as the colon. So all we want to say is, once I've lexed this, like the number, or no, we want to do something more like this, don't we? We want to say, actually lex this whole stuff, and the result of lexing is going to be let x, and then it's going to be a colon, which is going to, I think, going to be colon like that, which is going to be at 5. And then an equal sign, which is going to be at 7. And then a 3, which is going to be at 9. And a semicolon, which is going to be at 10. And I think that's it. So, already the compiler is guiding us that there is no colon function on token. So let's make one. Where should we put it? Let's put it just before semicolon, shall we? It's going to work pretty much like semicolon, I guess. So let's just copy that. Semicolon is made from a semicolon type, like so. And we're going to need to make a colon variant. Let's put it just before semicolon. Or are these in alphabetical order? No, they're definitely not. That's a problem. Why are they not in alphabetical order or some other logical order? Yeah, okay, that to do. Ignore that to do. Ignore that to do. All right, so it's complaining because we've added a variant and there must be some code that is... really? Variant code was never constructed? I guess in production code, the variant code was never constructed. So now when we run our tests, the lexing fails because we don't actually know how to deal with a colon. So let's have a look at the code of our lexer and figure out how it works, and well, remember how it works. So basically, every time we get a character, we deal with it, and we can just copy how we deal with the semicolon, I think, and it's pretty straightforward because it's only ever one. There's never a colon that's part of some longer token or something like that. So we can just say straight away, if I'm not in the middle of something like a string and I hit a colon, it must be a colon. And it's exactly 1 byte long. That should be that. Is that going to lex? Close. What did I do wrong? So let from 0 to 3, x from 4 to 1, colon from 5 to 1 equals... Oh, I missed the I32. I just missed part of this... I missed out part of the code, so we better put that in. So this is going to be, I guess, another symbol, which is, that one is what's at 7, and then 4 characters on from there is the equals, and 2 on from there is the 3, and 1 on from there is the semicolon. And I think parsing this as lexing this as a symbol is totally fine. Like, it starts with a letter, should already be recognizable as a symbol, hopefully. Alright, what have I done wrong now? This looks pretty good. So, let from 0 to 3, x from 4 to 1, 4, x at 4, colon at 5, 1, I32 symbol at 7, 3. 7, 3? Why does that say 7, 3? Oh, it's how long it is, not how... I thought that was what line it was on. What is that? Yeah, it starts at 7, it goes on for 3. Yeah, I was a bit confused. Okay, so yes, we've done it. All right, so now we've successfully lexed this assignment, but parsing this assignment is not going to work. And I reckon in this video we've got time to parse it as well. So let's have a look at that. That's going to be in the parser. And let's find a test for an assignment. So we've got parsing assignment and usage. That's the one we just wrote, so that's probably pretty similar to what we need. So let's copy this whole test and put our new code in there. like so. And let's call this parse assignment with... Now, obviously, there is assignment in Rust without this equals part, but we're not dealing with that yet. Like, that's another thing we have to figure out whether a variable is uninitialized. Just seems like scary, so we're not dealing with that yet. That's why I've got the 3 in there. Parse assignment with type declaration, I think that's a type declaration. Let's say it is. Okay, so the answer to this is not this whole second thing, just this first thing. So it's a statement containing an assignment of x to 3. So that's all fine, but actually an assignment can optionally have a type, can't it? And we haven't allowed for that in our assignment thing. So I guess we just have to have type. Are you even allowed type? I think we need to put an underscore there to make it an allowable thing to write here. And it's optional, and it's a symbol if it's there, right? Symbol token, I guess, is what we're calling them here. Am I still comfortable with tokens? Well, right, that's not for now. But we're holding tokens inside the result of parsing. Should these not be some kind of symbol syntax instead of symbol token? Because a token comes out of the lexer. But anyway, not to think about now. All right, so that's going to cause some compile errors because we're making assignments without providing types. So let's just find those and fix them. So this, we're not using the type, but we are about to, so that makes sense. And that means assignment needs to take in that, which was a symbol token. And then, that needs an underscore. Not sure if naming it with an underscore is sensible. We'll just put an underscore at the beginning because that does have a meaning, which is, this is unused. Where else have we got a problem? Hopefully mostly in tests. So this is going to be... So let's start off by just populating this with symbol token, some kind of empty symbol token. Let's just call it foo or something. And a fake span as well. And it should be... Oh, so we could have just filled that in with none. That would be better, wouldn't it? Okay, what else? Right, so now in tests... oh gosh, that went funny, didn't it? Now the type should be none. Because there's no type here, so that makes sense. And here the type should be none again, because again there was no type in that statement, and we've already provided the type. No, we haven't. And now we need to provide the type here. And this time it's going to be something. It's going to be a symbol token, and it's going to be I32, and its span is going to be from 1, 2, 3, 4, 5, 6, 7, 8, 8 for 3 characters, I think. Is it really at 8? 0, 1, 2, 3, 4, 5, 6. So no, it's at 7. Like the previous test had it at 7. And that means, of course, that the 3 is no longer at... I said 7. The 3 is no longer at 8. It should now be 1, 2, 3, 4 or further along than 7, which is 11, I think. Well, if I got that wrong, we'll figure it out when we do it. So now we should have a few tests failing. it's failing because there's an unexpected X. Is that really right, or is that? It feels it should be complaining about the colon. It feels like it's complaining about the X, and it's not saying which token was unexpected, which is a problem. So let's try and fix that problem if we can, and make it actually say what thing was unexpected. Does Rust do that? Let's try. What if we put like a I don't know, a carry symbol here? No. What token would be not actually expected? £? Unknown start of token. I kind of want something that it knows about, but it doesn't expect here. No, that would be fine. No, that would be fine too. What about a closed bracket? That's an unexpected token, isn't it? I think we're not going to get it to say what I want it to say. That's just too clever. What token is definitely not allowed here? %? No, it's going to say something. Basically, every time we do something wrong, it's going to say something much cleverer than what we're doing at the moment. Yeah, it's like saying there's some kind of expression going on when... well, what was the £? Was that any good? Unknown start of token. That's basically saying you're not allowed that symbol anywhere. But yeah, it does say, like in this case, it's confused, like it's trying to use ASCII in its description of it. But basically, it's saying £, was not expected to be found there, or like I know there's no a token's not allowed to start with a £, or something like that. So we should be saying, what I'm getting at is we should be saying unexpected token : if that's the right answer. So let's take a diversion from getting this thing to parse, to get the parser to tell us a little bit more clearly what happens. So the unexpected token here is 21. So what did we write in, what did Rust say? Yeah, a colon and then the thing that it was talking about. So I think it should say that, right? So let's disable our test that we're actually using for a second. So we've only got one failing test. And let's try our new test that we're failing, which is it should be saying what token was unexpected. So let's look for where we say unexpected token in the actual code, and we should be putting something in here. Oh no, this is another error. So this should be saying unexpected token plus, I guess. And here's where we actually say unexpected token. Should be saying unexpected token. Blah. And when we actually create this error, we need to pass that in. So I'm not sure whether this is right. But if I say token in here, what happens? Okay, this might be the right way to do this. And that means somewhere where we're actually creating this error, we need to say what the token was. Which I guess is symbol dot. Oh, we need the actual text of it. What is a label? Can we just use the label? Can we get the actual text out of the source span? Maybe we don't even need this token thing. Let's go back and see whether we can just say something to do with label, like, can we say please just give me the actual text? I guess not. Because at the moment this span doesn't actually know the actual text. So I guess our two options are something a bit cleverer, like maybe there's some stuff to do with this error that or Miette that gives us what we're looking for that we can print in here. Or we need to pass in the token somehow by like going and looking it up in our source text manually. Let's have a quick look at what we can do in the Miette error macro, whatever that is. So we've got Miette, we've got source span in fact, so we're kind of close to what we are looking for. Does formatting, now this is debug for source span, right? So the source span is just like a length and an offset, right? So it's not got the actual information of what we want, which is the actual code. So let's have a look at error. If I can type in the right place. I was expecting an error like macro expansion thingamabob. Does this not come from Miette? Maybe it comes from this error. I mean, let's search for source code, source underscore code, because that's definitely a Miette thing. Okay, that exists. So let's just let's see if they explain to us how to use Miette. So look, this says missing field foo. So that's using some kind of text that's been given to it from somewhere. So, oh look, unique error codes. We could use that for our error codes. Generate fancy diagnostic output. That seems like the right type of thing. Error just says oops, but then the diagnostic gives us some more stuff. But I want the actual error message to have something interesting in it. But I'm not seeing any hints so far of how I would do that. Yeah, just a lot of kabooming and oopsing. And whelping, look. But then maybe if I look at how stuff gets stuck into diagnostic. Interesting that there's this going in there. Not sure what that's used for if there's nothing in there. This should be 6. Just wondering about where we're substituting in stuff that comes from the actual problem that we've identified. And all right, I'm not there. So maybe there's a better way with Miette, and do let me know if you figure it out. Meanwhile, we'll continue with our plan of supplying a token, which means whenever we hit an unexpected token, we need to pass in a token. And the way we're going to do that is we have presumably got code somewhere in self, maybe. Yeah, file contents. And symbol, I guess, the beginning of the span to the end of the span will give us a slice, which we can then to-owned on to get a string, maybe. And maybe that will give us a token that we need. And, there's lots of other places where we've basically got to do the same thing, I think. So let's try this. This does feel pretty awkward, doesn't it? Like this should be, the error system should be doing this for us. And also I've probably done it wrong. Well, this is not called symbol now. Just called E. I wonder why it's called E here. Okay, what else? Another place which looks the same. So, same again. Yeah, the fact that we've got this label that's already coming in. Now, what are you complaining about here? What are we complaining about? What's the problem? The actual error is here. Okay. The error is that symbol got moved already. Oh dear, I see. Well, I guess we could grab the token before. Really don't like that now. But we can just let token str equal symbol. No, we haven't got a symbol yet. Well, yeah, symbol's here. Okay, we've got a symbol. We've got a symbol now. Yeah. Equal. Right, this thing here. Am I going to have to do this everywhere? Maybe not. Token str. No, the to-own needs to happen earlier so that we're not holding on to a reference to something that is later used. Right, no, I'm not going to have to do it everywhere. I wonder why. Okay, it's because, yeah, this is the only place where we're actually supplying a token? No, there are other places. I don't know why. Never mind. Let's see if it gets us a bit closer. So, no, because we haven't. Why not? Panicked at line 87. Okay, parser, line 87. Is this new stuff? No, it's exactly here. Oh, this shouldn't be. Okay. This is not how this works. It should be. The second number is a length, not a location. So when we're slicing, we need to convert it into a location. There's a bunch of other places where we do the same thing. So presumably they're going to be wrong too. This all just feels like a terrible. Like they're definitely going to need to fix this. It all feels totally wrong. But let's just make it consistently wrong. Or not even wrong. It's not wrong. It's awkward. But let's make it consistent. Like so. Any more? Okay, I think we're done. So, how does this look? All right, all our tests passed, which is really surprising. Okay, well, that's great. So, I'd kind of like that to be a separate commit. But can we do that? I also hate it, but that's a different problem. And I don't think I want to untangle these commits. We'll just call this part of that. All right, so let's unignore our ignored test. Let's see if we can get this to parse, and I think that'll be easily enough for this video if we can. So the test is failing because X is unexpected. Now that's clearly wrong. The colon is unexpected, but somehow we are confused about what was unexpected. All right, so we're parsing. We've seen an X. Let's get to where we actually parse things. So we're parsing, and we look for an expression, and an expression starts with either a keyword, either a let, or some other thing. So in this case, it's a let, so we go into the assignment. Assignment is looking for a symbol, and then well, hold on. It's looking for it's looking for a symbol. Then we do our little new bit of code that looks for, see, like, what thing are we looking at next? And the symbol, in this case, will be an X, right? And then it's looking for an equals. So maybe, okay, hang on. Yeah, so I felt like we should be getting to here, saying, look, this thing is not an equals sign. But somehow, either we're not getting there, or we're misreporting. I guess we're misreporting. We've got to here. But let's double check that by writing some stuff here, like we got here. We got here. Yeah, okay. So look, it printed we got here. So it is getting to the bit of code we thought it would get to, where this should be an equals sign, but actually we found a colon. But it's printing out then the wrong thing. And it's the reason why is because it's using symbol when it should be using equals. So it's very simple. And this bug was already here before we made this change, which is good. So we can fix it. And now it's saying unexpected token colon, but it's still in there. It's still pointing at the wrong place because we only changed it in one place. It should have been equals here as well. I feel like the fact that symbol's still in scope is kind of wrong, but it's not because it's used here, so I guess it's okay. All right, so now are we at least complaining? We're at least complaining about the right token. And we failed to test this case. I've just fixed a bug and there was no test for it. So I don't like that. So let's put the bug back for a second and write a test for this bug. So it's another, I was just saying we needed more tests for error messages, right? Well, here's one now. So parsing two adjacent numbers is an error, parse assignment. All right, so parsing, I guess we can say parsing an assignment with like the wrong. Parsing assignment with, let's just say non-colon, that'll get the message across, is an error. So we're going to just parse, let's just say, let the code be let x at equal 7, right? That at just shouldn't be there. Let's just say let x at 7, right? That kind of makes sense. That what's gone wrong is that the equal sign has been replaced with a at. And now we'll just put code in here and here. And we should get unexpected token at, and it should be, you know, somewhere like, we should be pointing at, the code should be printed out like this. We should be pointing at the at, like so. Hang on, should that line, no, it should be, what should it be underlining? Just the token, like that? Maybe. Okay, so something like that, and then this is going to be 1, 2, 3, 4, 5, 6, 7. It's going to be at position 7 on line 1. Now the 7s are confusing, so let's make this be a 9. And okay, so our test is failing that we're going to make parse, but this new test is failing because it panicked during parsing. But what we wanted it to, hang on, which test failing? Parsing assignment with non-colon is an error. Oh, hang on, it's parsing, it's failing at the lexing stage. So we need a symbol that we actually do recognize, but it's not expected here. I guess that one will do for now, but that's going to fail at some point later. So what about, I can't remember what other symbols we even support at this point. Does an exclamation mark trigger us the way we want? No, because the point is all these errors are coming from the lexer. And though the lexer prints the error pointing in the right place, so it's really confusing. Let's go back to the, no, hang on. What do we lex? We don't lex much yet. I guess the semicolon, and then we'll have a to do, right? Is this going to work? Yeah, that worked. All right, so we're going to need a to do in here. To do, when we support non-initializing assignment. That's a weird way. It's not an assignment anymore, but anyway, non-initializing assignment, or let's say let statements. This semicolon will actually be allowed. Replace it with another symbol that gets lexed. but is not allowed in this position. Okay. Like so. Yeah, we're not doing this now because there aren't, like, an @ symbol or something like that is not currently lexed. So hopefully by the time we have to fix this, our lexer will be more capable. All right, that was all a big waste of time to say our error message is wrong because it should first of all say semicolon because we changed it, and secondly, it's not pointing in the right place. So now we're pretty much there. We just need to go back and fix the bug that we found, which was where we said symbol.span. And in this bit, this particular place where we're looking for the equals sign, we should have said equals.span. All right, I know it's deviation on top of deviation on top of deviation, but we're back with all our tests passing except our guiding test is ignored, and the test that we're currently trying to make pass. It's failing, and it's failing because it wasn't expecting a colon. It's pointing now in the correct place to say that colon is unexpected, and we need to make it expect a colon. So we're going to go back to our parser. In fact, no, we're going to go back to our assignment statement and say, get hold of an equals, except now it could be an equals or a colon, or equals or colon. We may want to break this into multiple functions at this point, because this assignment function is getting a bit long. But anyway, so hang on, this to do is no longer relevant. So we can say this. So currently it's looking for an equals. It needs to be looking for either an equals or a colon. So this is now going to be a match statement, I think. Match equals or colon. And it's going to be token kind colon. I guess we can call that colon and do something. Or it's going to be a token kind equals. And that's going to do something as well. Or it's going to be an error, in which case we return, pretty much as we did before. We can get rid of this. All right, and actually there's nothing to do. Oh no, well, previously there was nothing to do with either colon or equals. Hang on, what have I done wrong here? So, this should be dot kind, right? Because it was always going to be an equals, so we would then just do this business. But if there's a colon, we actually need to do something, which might be a separate function, or it might be, yeah, there's no need for this. We can just, let's add a comment. Nothing to do. The value part, the right hand side is next. The right hand side will be parsed next. Or there's a colon, so that means we need to type. We need to grab the type. And that means now, actually there is something to do, which is we need to say let type equal this whole thing, and in this case just return none. There is no type. Nothing to do. There was no type. Specified. And this is going to be something thing, but we're going to need to like find the type. So I guess we're just going to ask for another symbol, right? So this is all getting it's getting a bit long, but let's keep going and figure out how we make it look nicer soon. Something like, oh, we've got to actually get hold of, yeah, I was missing a whole chunk of stuff. Yeah, we probably need, we need so much stuff to be pasted in here. This is definitely getting to be, so I guess we need a helper function that expects a symbol next. So let's put in a to-do for that. To-do. Helper function that expects a single symbol. Replace this, replace the below and the first part of this function. And hopefully we could make the actual assignment part still relatively small if we have some nice helper functions that make it easy to understand, maybe. Right, so grab ourselves a symbol, get hold of the token so that we can report what went wrong, and yeah, so I guess this is grab ourselves a token. There should be a token here. Keep hold of that token that we found, and then turn it into a symbol. If it's not a symbol, return an error because we expected a symbol. And then we can provide symbol as the value for token, for type, sorry. And the type of type should now be an option of symbol token, exactly what we need. We're still not actually using the colon that we get given here, so let's just have an underscore here and also an underscore here. There's just like, we're not using them, but now we can provide type because we found it, and we need a semicolon now. All right, so I think the compiler's happy. And of course, after our type declaration, we are then expecting another equals sign. So we need to do some really awful copying and pasting, which I will just do. We're just going to swallow up the equals before we return the type, I guess. To do helper function to find a single, I guess it's just a like simple token, isn't it? Or something like that. Maybe our helper function can do both of these. But anyway, for now, we will grab ourselves another token. And we're going to do the if not matches, I guess. Like we just deleted. If not matches. Which comes first when you do matches? Well, the given expression matches the provided pattern, but which way round? Expression then pattern. Okay. It's exactly the same as what we had. I mean, the answer is I expected a symbol got symbol. What on earth is this to do meaning? Expected symbol got token, I guess. Right, so yeah, when we don't find either a colon or a equals, then we return this thing. So we're going to do the same. No, it's not time for a break. So if we didn't find it, where's my to-do gone? Oh, it's here, yeah. And use it for below. And also further below, I guess. Right. So if the thing we just found, no, this is now going to be really keen for me to have a break. Now this is just looking for an equals. And if it doesn't match, and here it's just, again, it's all about equals. If it doesn't match with token kind, so equals.kind should be token kinds equals, then complain. Right. How does that look? Close, but not quite there, because we have somehow overwritten our variable name with the type, because I think we've reused it's because we've reused the name, I think. So if we found a colon, look for a symbol. That's kind of surprising that that's leaked out of there and ended up, I guess, in here. Yeah, really surprising. Is it because, am I somehow modifying symbol, or? I mean, it feels like all this happens inside the scope of this, so how can it? Alright, well, let's rename it. And see whether the problem just goes away. So let's call this the type symbol. It could be that it's something else that's actually causing the problem. It's not leaking out of the scope in some way that I'm missing. Try from type symbol, and this should be called type symbol as well. And then we're looking for an equal. Alright, so yeah, okay, we should be returning type symbol right at the end. Now, where is the symbol being used? Oh look, it's being used here. That's definitely wrong, right? It should be equals. No. No, I guess it should be type symbol. Type symbol. Yeah. Oh yeah, that was where it's hard to know what span you should be using, because we got to the end of the file, so we just give the last symbol that we were looking at, I guess. What else? I think that's all the places we use symbol inside here. Does that fix the problem? No, because something funny is going on. That obviously couldn't have fixed the problem, because things can't just leak out of the scope like that. So let's have a quick look at what we're doing. We're using the word symbol to say the X or whatever the variable name comes into here. We check that it is actually a symbol. We're trying to make a symbol token from symbol, which is a token. Fair enough. And that either works or it doesn't work. Now we're looking for an equals or a colon. And if it's a colon, then we look for another symbol, which is the type. Now, what is token here? Because that could be a bit wrong. Like, basically, if we broke this up into functions like I'm planning to, it's all going to be a lot easier to understand, isn't it? Where does this token come from? This should be type symbol. Yeah, we're doing far too much in one function, and that's why No, it shouldn't be. It should be equals or colon, I guess. It's basically the last token that we dealt with. Saying, oh, we got to the end of the file unexpectedly. I mean, this whole structure should be a little function, shouldn't it? Just saying, grabbing the next token. Oh, and if you hit the end of the file, say it was unexpected. Let me get hold of, I guess let's call this type token str, just to help ourselves with that. Now we try and turn it into a symbol again. And if it was a symbol, we're okay. Otherwise, return an error saying we expected a symbol and we didn't get one. Then we look for an equals, and we put the answer into equals. We check it actually is an equals, and if not, we return an error. And then eventually we give back that symbol. Or if it was an equal sign here, we give back nothing at all. And if it was neither, we have an error. Now we parse the next bit, which is the right-hand side of the expression. And I mean, this is really weird to me. How did the I32 end up in our symbol? And oh no, I'm reading it wrong. Type, yeah, okay, this was all fine. It was all fine. So this is an assignment statement with a symbol of X spanning 4, 1, an expression of a leaf token, basically an expression of 3 spanning from 13 to 1, and look, that's what we've got wrong. And then a type, which is an I32 from 7, 3 along from 7. So all we got wrong was that the 3 is in the wrong place. I was down a weird blind alley. My test is probably just testing the wrong thing. So let's have a look. All right, at least we rename some variables. Yeah, the point is that 3 is no longer where it was. It's moved along a bit. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Should be at 13. Now our tests are going to pass. Okay, so we got there. We managed to parse an expression which has an optional type, and we left our code a complete mess. So I guess next time we're going to tidy that up. Try and make this, try and make this assignment function a bit less of a mess, because look how many pages it is, and it should be only 1. Hope you enjoyed. Well, I was about to apologize for bumbling around, but really these videos are watching me bumble around, so you get what you paid for. Hope you enjoyed. See you next time.